Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 7, Trig, Lesson 4, Pythagorean Theorem, Part 2. Now, which expression is equivalent to cosecant squared of theta minus 1? Since Pythagorean Theorem, we go back here, we've seen cosecant squared, 1 plus cotangent squared. So I can write this as 1 plus cotangent squared of theta minus 1, or just cotangent squared of theta. So now you look at this and go, well, it can't be cotangent of theta minus 1, it can't be tan squared of theta, because there's no way you're turning cotangent squared into tan squared. And we just proved it's cotangent squared, not cotangent squared minus 1. So we're down to cosecant and sine, or cosecant and cos. You're going, what? But what is cotangent? Well, it's 1 over the tangent. It's also cos squared of theta over sine squared of theta. Now, can I write that as cos squared of theta times 1 over sine squared of theta? I can do it that way. Now, what is 1 over sine squared of theta? That's cosecant squared times cos squared of theta, which is d. Okay? So some of these you've got to play with and think about a little bit. Now, the next one, simplify. 1 over 1 plus sine theta plus tan theta divided by cos theta. Now, this is a bit of a pain, but as I said before, simplify everything sine and cosine. So, tan of theta that's sine theta over cos theta divided by cos theta. Now, sorry, this second term here or sine theta over cos theta times 1 over cos theta sine of theta over cos squared of theta. Now, why am I doing it this way? Because I can. Now, we have cos squared and we have 1 plus sine. If you think about it a little bit, where have we seen cos squared before in terms of Pythagorean? Well, right back here. Cos squared is 1 minus sine squared. So this is sine of theta over 1 minus sine squared of theta. Now I'm going to rewrite this. Plus sine of theta over 1 minus sine squared of theta. You're all going, what? I want you to think for a moment. Where have we seen something like this before? Well, I will give you a hint. This is 1 plus sine. Or if this is 1 squared minus sine squared, what have I got? A difference of squares. So, this is denominator is 1 plus sine theta times 1 minus sine theta. So when I'm adding them together, what denominator am I missing? Oh, what's my common denominator? 1 plus sine theta times 1 minus sine theta. Yeah, pain in the bum. Doable. So this is 1 minus sine theta over 1 minus sine theta times 1 plus sine theta plus sine of theta over 1 plus sine theta 1 minus sine theta. Now, need more space, so let's copy that. go. Notice that's why you have this blank space here. Now, what do? When we add, we have common denominators, so we add our numerators. This is 1 minus sine theta plus sine theta is 1, over 1 plus sine theta. That's 1 minus sine theta. And now I would multiply out my denominator, 1 minus sine squared of theta, or 1 over cos squared of theta. And that becomes secant squared. So that whole mess simplifies to secant squared. That's what I need you to be able to do. Now, can you do it quickly and neatly? Hopefully. Well, quicker than me. If you can, please show me. Excuse me. I'll be happy to change my notes. But that's what I need you to be able to do. So let's do a couple more. Now, let's solve this one. 3 tan squared of theta plus 4 sine squared of theta plus 1. So right off the bat, turn everything into sine and cosine. So the left side here, this is 3 sine squared of theta over cos squared of theta equals 4 sine squared of theta plus 1. So what have we got here? Sine squared and cosine squared. I suggest, I do strongly suggest turn everything into either sine squared or cosine squared. Now remember, this is going to be 3 sine squared of theta. Now the denominator becomes 1 minus sine squared of theta equals 4 sine squared of theta plus 1. So as I said, turn everything into sine squared. Now, this is getting confusing for me. I'm going to make sine squared of theta equal to x. Alright? Just because I want to simplify this mess. This becomes 3x for 1 minus x equals 4x plus 1. When I write it like this, it's not too bad. Cross multiply. It's 4x squared plus 1 minus x. Subtract 3x from both sides. Of course, I'm turning it into quadratic. 0 is equal to minus 4x squared. 4x minus 4x is 0, plus 1. Now, that's 1 minus 4x squared. Okay, now why am I writing it like that? Because I can. Let's go to the next page. Once again, if I wrote that as 1 squared minus 4x squared, we have a difference of squares. So this is 1 plus 2x, 1 minus 2x. Now remember, x is sine squared of theta. So this is 1 plus 2 times sine squared of theta, 1 minus 2 times sine squared of theta, all equals 1. So either 1 plus 2 sine squared of theta equals 0, in which case 2 sine squared of theta equals minus 1. Where theta is minus 1/2. Sine of theta is plus or minus the square root of minus 1/2, which doesn't work. Or 1 minus 2 sine squared of theta. Sorry, that equals 0, not 1. God help me. Forgive me, ladies and gentlemen, I'm getting old. So, minus 2 sine squared theta equals minus 1. Sine squared of theta is 1/2. Sine of theta is plus or minus the square root of 1/2. All that work to simplify this mess. God. Way too much work. Now, at this point, I just want to scream because I'm getting a headache. All this work. That was 0 to 2 pi. Just double checking. So, square root of a half is up here. And minus square root of 1/2 is down here somewhere, so we're going to have 4 answers. We can plug those numbers in and solve. I'm just getting old and lazy and tired. So I'll let you guys do that. Actually, I should do it myself, shouldn't I? If Mr. Calculator will turn itself on. Come on. Oh, sorry. So, y equals clear, clear. Sine of x. This would be second square root 0.5. Enter. Window 0 to 2 pi. Say pi divided by 4. Minus 1 to 1. Graph. Alright. So we got 2 intersection points. Surprise! Now, second, calculate, intersect, enter. Oh, don't do that, don't do that. Just stop that. Getting too old for this crap. Stop it. There we go. Enter, enter, enter. 0.7853. And, oh, wait a minute. I can still solve this algebraically. Because this is inverse sine negative second, sorry, square root 0.5, 0.785. Now, okay, so I can do this algebraically, and that will also be, second answer will be pi minus that, so 2.36. We do the same thing to find the negative values, and I suppose I should do that for you. Inverse sine negative square root 0.5 minus 0.78. So that's down here. We add 2 pi to that. That will be 5.50 right here. Now note that that is 0.78. It's 2 pi minus 0.78. This will be pi plus 0.78. Plus, oh, you gotcha. Pi plus 0.78, 3.93. So, that I expect to be able to do. Now it's getting kind of long, so I'm really going to pause the recording here. Any questions, shoot me an email. Otherwise, let's keep